Okay, in this video we're going to be talking about classification approaches to continuous data and the possibility of unclassified visual data. So what we're looking at here is a little bit different. We're looking at the environment in an arc map. But what we have here is elevation. This happens to be at McConnell's Mill. And so we have elevations in feet. And in fact, we can see it right here that a low value is 994 and a high value is 1335. But you'll notice that in fact there is no classes in the data. We simply see gradation in color suggesting variation. So we know that the darkest blue has a value, that's the low value, and that the kind of brightest brown has the high value. But we use this approach when we have continuous data so that we can kind of see how things are happening. But the downside of this approach is that in fact we can't see actual values. And in many cases for continuous data we use this unclassified approach. Now let's compare it to a classified approach that we've talked about in some of our other videos. And in this case what I'm going to do real quick is I'm going to take the data and I'm going to classify it into equal intervals. So we're going to hit class, and you'll notice the difference here. Most continuous data, I shouldn't say most, but many sets of continuous data will have something of a normal distribution. And so again, what I'm going to do here is put in an equal interval, and in this case, because we don't have to worry so much about color, I'm going to put in 10 classes. Makes a nice kind of even stretch here, and hit OK. And now what I'm going to do for this though is we're going to use a similar color scheme and apply it. And what you'll notice is that when we classify continuous data, we tend to get something that looks like our contour maps before, but with the area in between them filled in. Now what becomes a little bit problematic is that we lose, again, as we talk about anytime we classify data, we lose some of the details. We know that, for example, here is that stream area, again, low this time is brown or orange. And we can see, in fact, the steps up, but we know from our previous example that this is rather continuous data and a lot of variation, but now we have one class. Now the important thing also to do with this, though, is that for the most part with continuous data we tend not to use things like natural breaks or quantiles, but what we do all the time is the standard deviation approach. So imagine right now we're looking at kind of classed elevations. Again, we see the contour map in it. But what if we wanted to say, well, where's the average elevation across this, and where are the areas that are above average or below average? And we can imagine this, for example, in terms of precipitation data. And so in this case now this is elevation. We're going to click on the properties again. What I'm going to do here is I'm going to classify it now into standard deviations. And I'm going to say I only am interested in one standard deviation, and I get to see the mean. Now you'll notice here that the mean value is 1,178 feet at McConnell's Mill, or at least this section. So in this case, again, I'm going to choose a color scheme that allows us to see the middle. Again, right around here is our mean value. And when I apply this, now I have a different way of looking at landscape. Well, this is below the average. And again, this is above the average, and right through here is kind of the average elevation. Now I'm going to look at a slightly different data set here so that we can see this kind of in a big scheme. This happens to be, let me go out to the entire extent, this happens to be cell phone tower density in the United States. And in this case, this is per square kilometer. And if I were to look at this classified, again, it would be appropriate in this case, not quite normal distribution, but again, it's rather spread data. And I'm going to put this into an equal interval, 5 equal intervals, and apply that. And we can in fact see across the country we have fairly high cell phone density, not surprising where the high US population is, and then it fades out to the west. Well, and that's one way of looking at it, and certainly appropriate to look at cell phone densities in an equal interval. The other way, though, to see this, again, most appropriately, is through standard deviations. Again, we're going to classify this into our standard deviations, and again, we're going to apply a bivariate. If you remember when we talked about colors, we now have, here is in a sense the mean, and we have below the mean and above the mean. So when we apply that, Now we see very clearly kind of the averages throughout the Midwest, but along the eastern corridor is above average cell tower density. To the west, it drops into the lowest, in fact, two full standard deviations away from the mean, kind of this empty area, and then in Los Angeles it pops up again. So when we think about continuous data, the main thing to think about is that we can, in fact, deal with it unclassified. Simply see the range of values because the data varies so much. Or we can say, well, we want to drop it into equal intervals so that we can step across it much like a contour map. Or we can put it into standard deviations. Again, remember, that's an expert map from a previous video. But it allows us to very quickly see what's above average and what's below average. So that's a wrap-up of data classification over the next 2 class periods. Please make sure you've watched all the videos and have taken notes. Be ready for a quiz and then a practical exercise next Wednesday. Till then, we'll see you.